All right, welcome to today's lesson on combining events, where we have two events which possibly have some overlap. All right, now this is not two separate events where we'd use a tree diagram or a two-way table. This is more like we have a group of things that we could pull results from, and we can show them with a Venn diagram. All right, so we've seen this before. If we draw Venn diagrams, we have a few different areas we like to look at. So we can show those different areas by shading in parts of the Venn diagram. So if I wanted to show all of A, I would shade in all of the A circle. Notice that anything in the A circle was shaded in, even this part in here that is in part of the B circle. Doesn't matter. All right. Or if I wanted to shade in the B circle, I would do the same thing over here. Notice that part of the A circle has been shaded in. Doesn't matter. All right. What if I wanted to shade in the crossover? This is called the intersection, and that's just that bit in there. Now, when I say shading, it helps to shade because I'm visualizing the areas that the results can be in. Okay, so that's the intersection, and if you want to write that, we write that like this. Okay, that's the intersection. What if I wanted to look at a result that was all of, or possibly A or B? So I could have anything in the A circle and anything in the B circle, and I can shade them like this. You notice that it's not outside, it's just those parts there. And the way we'd write that one is A or B. Okay, so Venn diagrams are helpful in that we can visualize the parts where the results are coming from. All right, now there's a few other things to look at here. We've looked at intersection, we've looked at union. So just in case you don't remember, this one is intersection, and that is the part in the middle, the purple area. And this one is union, okay? The green part of both of them. The word we use for this is or, and the word we use for this is and. So it has to be for intersection, it had to be in both the A circle and the B circle, so that's and. For union, it could be in either, and it was still a result that we were looking for. All right, so a few things to write into your notes book there. Now, something else to look at is down here, where we have A and A complement. Now, complement means just not A, or whatever this one is, not that event. So the two results I have are, it could be an A event, which could be, flipping a head, or it could be not a head. All right, now it's a bad example because head's only got one other result. For instance, what about a dice? We could say it could be a 1 if I roll a dice, or it could be not a 1, in which case we have 2, 3, 4, 5, and 6. But I don't refer to it as a 2, 3, 4, 5, or 6. I refer to it as not a 1. Because in probability, those are the things I'm interested in. Certain thing happening or not happening. I'm not interested in the other possibilities. All right, so that's something to put into your book. Now, the last thing to put into your book is a certain type of event called a mutually exclusive event. All right, you notice here that A and B share no crossover. They are known to be mutually exclusive. A good example of this are where A could be girls on a hockey team, and B could be boys on a hockey team. All right, so you can see that there are going to be no crossovers in that region. These are going to be all the people on this team, and these are going to be all the people on that team. You can't have someone playing for both teams, okay? So that's a mutually exclusive event. So here's a type of question we'd be looking at doing. And these tend to be rather wordy questions. All right, so let's have a look. 50 students were asked what they did on the weekend. A total of 35 said they went to football matches, the movies, or both. Okay, so we have two events. So we're going to draw our Venn diagram. I'm going to put in our two circles. All right, we have movies and football. All right, it says 35 went to football, movies, or both. All right, so 35 are inside the two circles, but we're not quite sure where they are yet. 22 went to football. 12 said they also went to the movies. So there are 12 in the football circle and the movie circle. There were 22 in the football circle, which leaves 10 for there. All right, now it says there were 35 inside the two circles together. So we have 22 inside the football circle, which leaves us with 13 in the movie circle. Okay, now it says here that there were 50 students who were asked, but I only have 35 listed, which means that there is an additional 15 who don't do football or movies. Okay, so there's the information being shown on a Venn diagram. It says questions are, how many students went to the movies but not to football matches? So that would be my 13. All right, and I'd say 13 out of 50. How many went neither to football nor to the movies? And that's this part here, the 15 out of 50. Now you've noticed that I've written it as a fraction out of 50. This is because the future questions are going to be phrased along the lines of probability type questions, where you'd say, given that this is the results, what are my chances of picking someone out of the group who does a certain thing? And you would list it as whatever the group they belong to out of the total. Okay, so this question builds on from that and is exactly what I'm talking about. What is the probability that a student chosen at random from this group of 50 went to the movies but not to football matches? So that's this original 13 here. So this is when we're asked about probabilities, we should phrase it as a fraction. 13 out of 50. All right, and I can say that this is PR of not F intersection M. Now I say that it's not F intersection M because not F is everything outside the F circle, including the M circle. But I am not interested in everything outside the F circle. I'm only interested in the stuff in the M circle. So I have to phrase it as not F intersecting with M. All right, because if I had just said PR of M, that would have been everything inside the M circle, which is half the students. But that's clearly not right, because we don't want the people that also go to football matches. All right, so we have to be careful with this notation here when we use it. Question B, what is the chance that a student chosen at random went neither to football nor to the movies? This one's a little bit easier because it's these 15 people sitting out here. So we can say that this is the chance of PR not F intersecting with not M. All right, now because there are two events inside this Venn diagram, we have to use the intersection to show that it's the people who are not in either of the circles. All right, so this is just that 15 out of 50. And if we can simplify, we should, and this one goes down to 3 out of 10. All right, so we can work on this notation, that's not a problem. All right, but just keep in mind that the goal for today's lesson is to be able to pull probabilities out of Venn diagrams. All right. Now, the last thing that I'm going to give you today relates to this intersection, and it's a little formula called the addition rule. And the addition rule looks like this. It's just a little formula that relates to unions of Venn diagrams. All right, so let's just pull it apart. So we have the A union B, so that's the green areas in this Venn diagram, is the same as the chance of A plus the chance of B. Now, you might think that's pretty straightforward, all right? But the reason we have to subtract out the intersection is because if I count everything inside the A circle and everything inside the B circle, you can see that I'd count this little part in here twice, can't you? If I counted all of that and all of that, I would count the intersection twice. So I have to subtract it out once to make sure I only get it once. All right? This is called the addition rule. Okay, and it is a way of calculating the union of two sets. All right, it applies in all situations and is always true. Okay, so we'll just do a quick example now of what that looks like. All right, so this question says, if one card is chosen at random from a well-shuffled deck, what is the probability that the card is a king or a spade? Okay, so we've got king or a spade. So the Venn diagram would be pretty simple. We would have crossover here, king, spade. Now, obviously, well, maybe not so obviously because I'm not sure how often you guys play with cards now, but obviously there is a king of spades. So there is some crossover in here where you can have a king and a spade. All right, so we need to make sure that we don't calculate that one twice. All right, so let's see. How many kings are in a deck? We have 4. How many spades are in a deck? We have 13. All right, so the chances of pulling a king out are 4 in 52. The chances of pulling a spade out are 13 in 52. And I have to subtract the chance of pulling the same thing out. So I have to have, there's a 1 in 52 chance that I'll get the king of spades because there's only one of them. So this is the addition rule in action here. And I can write it here, king union spades. All right, so I'm going to have 4 in 52 plus 13 in 52, take away 1 in 52, and that's going to give me 16 in 52 chances of having a king or a spade. All right, so this is the addition rule in action. We can see that this has to be subtracted out because there is one card which is both a king and a spade, and if I just added those two things together, I would have counted that one card twice. Once in here for kings and once in here for spades. So the addition rule helps us get around that by subtracting out the final chance. All right, so I hope that made sense. You got a few things to put into your notes book, and then we have some questions to try.